All right, 8.6 natural logarithms. So we've talked before about the irrational number e, which is about 2.72. It's used to model continuous growth or decay. So in another video, we talked about when is cash in our savings account. When do we get our interest on that? And it was modeled, I think, on monthly for that one. Whenever we use e as our rate, it models not our rate in our equation. It models continuous growth. So every moment something is happening, something is increasing or decreasing. So if we look at y equals e to the x, that can be converted into a log, right? Log base e of y equals x. But a log base e, just like how we had log base 10 is kind of special. Log base e is special as well. It's called our natural log. And it is abbreviated ln, and you don't have to put the e there. So lny is the same thing as log base e, right? This here is a big idea. You need to make sure that you know that, or just the plain old ln piece. You need to know what ln means, right? We're going to use that a lot, and that's used a lot in math. Really, you're taught, or whenever I went through, I was taught about logs, and I learned all the properties of logs. And then pretty soon after that, we just use natural logs. And natural logs can be used in statistics and some different things. So natural logs, make sure you remember ln is a natural log. It's log base e. Something that you might have picked up on while doing your homework is anytime you have log base b of b, that's equal to 1, right? So you could say you've got like log base like 2.5 of 2.5 or log base 10 of 10. Those are all equal to 1. Whenever the base and the piece inside the log is the same, it's equal to 1. So like I have written here, log with no base, right? So that's log base 10, our common log. Log base 10 of 10 is equal to 1, right? I'm reading right there. And then below it, we have the natural log of e, and that's how we read that, the natural log of e. That's equal to 1, right? Because this is the same thing as log base e of e, right? We're going to use that property sum to solve these here. It's going to speed it up, and it's going to help us out. A lot of the time, there's ways to get around using that property, but it speeds up our homework. It speeds up these problems quite a bit. So that's what we're going to be doing. I'll zoom out so you can copy stuff down if you want, and I'm going to continue on to the problems here. Number 1, e to the x equals 15. So the fastest way that I can see to do this, we could convert it into log. Well, you know what? Well, I'm just going to illustrate this example. We could convert this into logs, and we could say, well, x equals natural log, or I'll write it the other way, log base e of 15. We can do that, and what we did there is we put your exponent all by itself, and the e became the base, and that's fine. That's more or less what we're going to do, but I think writing it the other way makes a little bit more sense. What I'm going to do here is I'm going to put a log on both sides of it. So I'm going to say natural log of e to the x equals natural log of 15, right? I did something to both sides of the equation. Now my x can come out front because it's an exponent. So x natural log of e is natural log of 15. Natural log of e is 1, so it can just disappear, and x is natural log of 15. Now you might say, well, I got to this really quick. That just took one step, and we got to the same thing, right? You can do it the other way if you want to. On some of the other problems, it will be a little bit easier to do it this way on the left, to do it the way that I showed you there, the longer way. That's the way that I would suggest doing a lot of these problems. So now that we have x equals natural log 15, I can press equals on my calculator. I'm going to type in natural log, if I can find the button, natural log 15. On my grapher, it's in the lower left corner. Natural log 15 is about 2.7. We'll say 2.71 maybe. 2.71. All right, next up, number 2. So like I suggested in the last one, I'm going to take a natural log of both sides. But before I can do that, I need to get rid of this 7. So I'm going to divide both sides by 7, and I'll have e to the 5x plus 8 equals, in my calculator I'm going to say 0.23 divided by 7. That gives me a very, you know what, let's just leave it as 0.23 over 7. That'll keep it more precise. Let me make sure this is still connected. Oh, it is, okay. Now I'll take a natural log of both sides. So I'll have the natural log of e to the 5x plus 8 equals natural log of 0.23 over 7. I'm going to take this exponent and put it out front. It'll be in front. And then my natural log of e then will be 1, so it can just go away. So I'll have 5x plus 8 equals the natural log of 0.23 over 7. And what we're doing there, we are using the property of log, where how to convert things from exponential to logs, but I think this is much easier to visualize for me. It's much easier to use. So again, I'm not going to type in my calculator because I want to keep it nice and precise. So this will be 5x equals, I'm going to subtract my 8, natural log of 0.23 over 7 minus 8. And then I'm going to change this to x is 1/5, big parenthesis, natural log of 0.23 over 7 minus 8. Now in my calculator, I just type it in one time, 0.2, parenthesis, natural log of 0.23 divided by 7. I make sure I close my natural log parenthesis, right? Our calculator naturally wants to open a parenthesis there, so I have to close it. Then I'm going to say minus 7, and then I close that parenthesis. And I got negative 2.28. And there we are. Moving on, number 3. Number 3 gets slightly confusing because we have that natural log in the exponent as well. But to start off, we're still going to do it the same way that we had done them previously. I'm going to do a natural log on both sides here. So I'm going to have natural log of e to the natural log of x equals natural log of 21. Oops. I'm going to take this out front because it's an exponent. So natural log of x times natural log of e is natural log of 21. Well, natural log of e, that's just 1, so it can go away. Now, we can actually drop the natural logs on both sides. And the reason we can do that, or you can think about it a couple different ways. We have our x inside the natural log. We have our 21 inside the natural log. So it makes sense that x would be 21, right? This would be the same thing as saying, like, well, the square root of 4 equals the square root of x. You're like, well, x has to be 4, right? We're using that same idea there. And so we've got 21 as our answer. Moving on, number 4. Before we can take our natural logs and get our x out of the exponent, I'm going to get rid of the 5. So I'll subtract 5 to the other side. So e to the x plus 6 will be equal to negative 4. And then I'll take natural log of both sides. And while I do that, I'm going to take this exponent to the front. So this will be x plus 6 times the natural log of e is equal to the natural log of negative 4. So let's pause right here and let's think about what's happening here. We have the natural log of negative 4. Can we plug a negative into a log? The answer is no. So this is actually going to be no solution. Right? So again, the reason that it is no solution there is because you can't get a negative out of a log. Right? Or excuse me, you can't plug a negative into a log. You know what? I'm questioning myself. Let's go ahead and graph this and make sure that this is right. We'll graph e to the x plus 6, and we'll have this equal to -4. We'll say y equals -4. That way it'll actually graph it. So here we can actually visually see what this is. The red curve is the e to the x plus 6, and the blue curve is the -4. So what I'm graphing is I'm graphing at this step here. So you see that they will never touch each other. They will never work out. So yeah, it is no solution. All right, number 5. Now that we got that one. Number 5. Oops. Starting off, let's divide by 2 to get our natural log all on its own. Natural log of 3x minus 4 is equal to 7/2. And I'm just going to leave it as a 7/2. Now, we want to get rid of our natural log, so let's log base e. Let's convert this to exponential form. So this e will come over here, and it'll kick the 7/2 into the exponent. So we'll have 3x minus 4 equals e to the 7/2. So this will say 3x is e to the 7/2 plus 4, and x will be equal to 1/3 times the quantity e to the 7/2 plus 4. And that's something we can type in our calculator. I'll type in 1/3, 1 divided by 3, times the quantity. So that's me opening a parenthesis. E to the 7 divided by 2 plus 4. And I got 12.37. 12.37. All right, there we are. Number 6, almost done. Well, here we have 2 natural logs, and we can't get rid of them both together, so we're going to have to put them into 1 first. So because we have this addition sign here, I know I can multiply them. So I'm going to multiply the x and the 3x. This will be natural log of 3x squared is 14. Now I want to get rid of my natural log, so I'll move my e over here, move it into exponential. So 3x squared will be e to the 14. So x squared will be e to the 14 over 3. And lastly, we have to take our root, so x will be plus or minus root e to the 14 over 3. But the thing to ask ourselves is it actually plus or minus? And if we go back up here, that tells us that our x has to be positive, because we can't have a negative x. So this is actually just going to be the positive x. So square root of e to the 14 divided by 3. That gives me 633.14. And I'm going to type that back in my calculator and make sure that that works. So my original is natural log of x, so I have natural log of 633 plus natural log of 3 times 633. And did I close my parenthesis? I did not. All right, there we are. And that's equal to 14 whenever I typed it in, so we're good. This is our answer. Right, and I plugged that in just because that 633 may be uncomfortable. That's a much larger number than the rest of them, our answers, so I just wanted to double check that. Lastly, number 7. So starting off, I'm going to divide by 3 on both sides. So that'll change it to natural log of e to the 2x equals 4. Well, this natural log of e piece, we know that could be 1. Right? We want that to be 1, but we're going to have to get rid of that exponent first. So this will be 2x natural log of e is 4. So 2x is 4, and x is 2. So that one's not too crazy at all. All right, make sure you know how to do these problems. Make sure you especially know how to do the ones whenever you have a plus or minus or some kind of root. Make sure you pay attention to the way that number 6 was done, where we multiplied those together. All right, that's all. Good luck on the homework.